The site that I'd like to speak about is a former industrial site from Bosch Corporation in Japan. It was demolished in 2008, and Bosch has been seeking to exit the facility since that time. It was quite difficult for them to find a potential buyer due to the existing contamination that was there. Not all of the impact had been previously identified or delineated. That was a task of CDM Smith. We started investigating the site in 2012, and we continued to investigate until 2017. We've identified several source areas of chlorinated hydrocarbon impacts, as well as hexavalent chromium impacts from a former galvanization facility at the production site. It was a former automotive production site. And following the comprehensive investigation program, we designed and performed a remediation according to Japanese standards for the entire facility. So the area in question is it's a site in Saitama Prefecture. It's in the city of Higashi Matsuyama. It's a 55,000 square meter site. And as I mentioned, we had chlorinated hydrocarbon impacts. We had some total petroleum hydrocarbons up here in the upper portion of the site. However, it's not shown on this map. And there were also hexavalent chromium impacts below the saturated zone at depths below 7 meters. These were formerly remediated until the saturated zone by another firm. But the residual contamination at to vertical delineation and remediation had not been achieved. That was part of our remedial program as well. So the focus of this presentation is on the chlorinated hydrocarbon impact, but I will speak briefly about the hexavalent chromium. So the site geology, it's located on an alluvial fan terrace. There are several interbedded layers of loam, sand, clay, gravel. When I say there's no significant aquitard within the area of interest, I mean in the contaminated source areas, there is a distinct groundwater. Two distinct groundwater zones, an upper and a lower aquifer, over most of the site. However, in the source areas, there are several gaps within that aquitard. So it's really one aquifer as far as the contaminated area is concerned. There is a lower aquitard at about 15 meters below ground surface. Hydraulic conductivity. 10 to the minus 3 centimeters per second, so relatively good hydraulic conductivity. Groundwater flow west to east. So when you see this map, this shows a portion of the site in the upper right corner. These were the main source areas of chlorinated hydrocarbon impact. In 3 grids, they're 100 square meter grids. According to Japanese requirements, contaminated sites or potential contaminated sites need to be investigated and delineated in a grid formation. And we've achieved that between 2012 and 2017 by installing over 80 groundwater monitoring wells. We've conducted hundreds of soil borings, soil vapor investigations as well. Everything according to Japanese standards. Following the investigation of the site, we designed the remedial program for these 3 source areas, being here, here, and here. And we've also identified, within this down gradient, or within the source areas, excuse me, we've identified groundwater impacts from chlorinated hydrocarbons as deep as 15 meters. There were also soil impacts from chlorinated hydrocarbons. Soil concentrations were as high as 1.5 milligrams per kilogram Japanese law requires that this be noted as milligrams per kilogram and milligrams per liter rather than micrograms per liter. So it's maybe the units are a bit deceiving in that you may be used to looking at that in micrograms per liter. So these remediation program, according to Japanese law, there's the Soil Contamination Countermeasures Law, the JSCCL, and that is a remedial approach, which is somewhat similar to the United States in that it allows you to develop alternative remedial processes remedial options for the site. However, these all need to be developed in coordination with the regulatory authorities, and they have to be certified by the regulators before you may begin remediation. So the focus in Japan is really on removal of source areas, and under the Japanese philosophy, you know, the groundwater plume, once the entire site has been investigated and the groundwater source contamination source areas are known, the groundwater plume is secondary. So the focus is really on soil remediation. So in order to do that, the Japanese requirements within the source areas require that soil for PCE and TCE be remediated to 0.1 milligrams per liter, and in groundwater, excuse me, that probably should be milligrams per kilogram. So groundwater is milligrams per liter, and vinyl chloride, the standard is incredibly low. It's 2 micrograms per liter is the target, and that's the target which we had to achieve following the source area remediation, and we were able to do that, and we're now within the 2-year monitoring program for the site. So the initial approach was excavation of soil impacts, followed by in situ treatment using a carbon amendment from a corporation called EcoCycle. We used a product called EcoClean was the product that we used as a carbon amendment. And following that, we also performed injections using zero valent iron. So the first area the first step of the remediation was soil excavation in one of the grids, and this grid was impacted by chlorinated hydrocarbons up to 1.8 milligrams per kilogram. And so that was excavated to a depth of about 4.5 meters. And we backfilled the excavation pit using zero valent iron mixed with backfill to treat the perched groundwater that was present at the site. And that was the extent of the soil remediation. Groundwater remediation was a bit more tricky. We performed in situ bioremediation using the product I just mentioned, the EcoClean product. So Super EDC is what the brand name, and we used this carbon amendment to encourage bacterial anaerobic biodegradation of the impacted grids, and there were multiple injections performed. I don't have the exact number in my head because we are still in the monitoring phase. We have not yet written the remediation report so far. So following that, we also performed some soil mixing using zero valent iron in the upgradient areas of each boundary grid and within the boreholes themselves within the grids. So groundwater performance monitoring, this was required immediately following the injections or the completion of the injections, and the parameters required were total organic carbons, oxidation reduction potential, pH, ferrous iron, chlorinated hydrocarbons, and ethene. And following this performance monitoring, we were able to determine that some additional injections were required. So is a kind of an overview. During the remedial activities, Japan is often impacted by typhoons, which causes the groundwater levels to fluctuate widely, and with a aquifer that's as transmissive as this one is, we were negatively affected by these water fluctuations. Following the injection work that we performed, we performed some post-injection soil sampling, and we determined that with the water fluctuation, some of the shallower soils had been recontaminated by chlorinated hydrocarbons from lower depths, and due to the infiltration, or I guess lack of a better word, from the elevated groundwater levels. And so we had to take a modified approach to our remediation, rather than only using the super EDC product, using vitamins and carbon substrate to stimulate the anaerobic bacteria. We also developed an approach to inject high pressure carbon zero valent iron to inject zero valent iron into the shallow soils and into the groundwater. And we also performed some additional ZVI soil mixing in one of the grids to ensure that anaerobic degradation was able to continue. And this was done using a forced injection approach, using a double packer injections. You can see the timeline here. The first well installations, the site investigations were completed in December of 2017. We installed the first wells for remediation in the remediation grids in 2018. And the first injections were performed 2019, and then we followed that up with the performance monitoring, some additional source investigations as the areas had been recontaminated from the high water table fluctuations. So the double packer injection work had been performed in August 2018, followed by some additional soil mixing, and we created a zero valent iron barrier at the grid, so that further cross-contamination from up-gradient off-site sources did not occur. This was the issue at the grid in the upper right corner from the map that I showed you previously. And with a plume of CHC entering the Bosch site from an off-gradient or off-site up-gradient source, it was necessary to secure the source area of impact on site, so that we could ensure remediation had been completed to the satisfaction of the regulators, so that a remedial closure letter could be granted. The final remediation work was completed in January of 2019, followed by some compliance sampling, and now we are in the groundwater monitoring phase of the program. According to Japanese standards, this must be completed for a 2-year period, and that will be concluded in February 2021. So when we talk about performance monitoring, you can see when we first performed the first injections, you can see that the concentrations of the PCE and trichloroethylene degraded to cis DCE, as you would expect, and to vinyl chloride after the first injection. You can see the spikes in vinyl chloride here following the first injection. And so supplemental injections reduced or degraded the vinyl chloride. However, the typical monitoring value of ethene was not detected in any of the monitoring rounds following the degradation of the vinyl chloride, so that was a bit unusual. However, following some following the high pressure ZVI injections using the dual packer, we were able to detect some ethene following that. So since February of 2019, we have been able to observe all concentrations are below the Japanese standards since 2019 in all three grids. So it was a very successful remediation, and we hope that the concentrations continue to stay below standards, because if there is a spike in concentrations according to Japanese law, then the remedial measures must be completed to the satisfaction of regulators, and then you have to start another 2-year monitoring program. So we're very much hoping that our remediation that we've performed nearly 2 years ago is able to continue, and that we do not see any further spikes in CHC concentrations until February of 2021. So if you look at the trends from over 2 different grids, here's two of the contaminated grids, C57 and E51, and we have similar results in B61. You can see that degradation has occurred, and all of these standards have been met. We were not able to do that, of course, until we did until we modified our treatment program from the super EDC to using zero-valent iron injections. So in a summary, the initial results showed that we had degradation, but it wasn't enough to meet the requirements from the regulatory authorities, and we were not able to achieve this during additional injections. And however, we found the approach using the zero-valent iron amendment injections in targeted areas following additional delineation of this impact was very effective. And in this circumstance, zero-valent iron seemed to be the game changer for remediation of chlorinated hydrocarbons at this site. So post-remediation monitoring results. You can see all of our concentrations are below the required thresholds. The most risky concentration, really, the parameter is vinyl chloride, as the regulatory standard is 2 micrograms per liter. It is very, very difficult in any circumstance to meet that objective. However, we've been very successful in this situation. So following the initial remediation, we also performed some soil monitoring. This is no longer required. We're now only in the groundwater monitoring phase, but the initial soil monitoring results were also below the Japanese standards. So in summary, we needed a very short-term remedial approach. We had less than 1 year to complete the remediation, followed by 2 years of monitoring. The remediation was needed in a hurry as our client Bosch wanted to sell this property and had an interested buyer, but the buyer was looking for a highly discounted rate or price for the property, and as you can imagine, this property is in the greater Tokyo area, so real estate values are at a premium. Bosch was determined to remediate this property on their own, and since CDM Smith has been a long-term consultant to Bosch here in Germany and in other places of the world, who I see Mr. Ebert is now joining the conference. Mr. Ebert is the client manager for Bosch worldwide for CDM Smith, and Bosch put their trust in us, and we were able to perform this work within a year using a combined team, which was based in Germany, being myself and Mr. Ebert, as well as our technical division remediation manager, Mike Lamar from CDM Smith in Denver. And we met in Japan several times and worked together with our Japanese partner firm, led by Hironori Kamemoto, who's leads a company called EAI, and they're based in Tokyo. So with this combined team of local expertise, client management, and corporate knowledge, and using our technical services group, we were able to rise to the challenge and complete this program. So in the end, we were able to save our client up to $15 million. I won't tell you exactly what the remediation contract amount was, but with the property value and the discount that they were looking for, that the potential buyer was looking for, it made perfect financial sense for Bosch to remediate this themselves and then be able to sell the property at a premium rather than giving it away, for example. And so now the site has been completely redeveloped and is now a commercial shopping mall. It's as you can see from the photograph, it's entirely paved and built up with the shopping center. One other thing that I would like to mention regarding the remediation, there were hexavalent chromium impacts at the site, and from the map I showed earlier, it was in the bottom right corner of the map. And so there were several grids of impact, and this also required remediation. It was achieved by I understand. Okay, well, so that will be for another presentation, but thank you very much for joining our discussion today.